Hello viewers, welcome back to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created several playlists on my channel for various categories of the problems such as BFS, DFS, dynamic programming, sorting, binary search, union find. So please check them out. Also, I have uploaded the code for this problem to GitHub. You can get the link from the description below this video. Let's jump into today's problem. So the problem is, check if it is a straight line, right? So you are given an array of coordinates of I is equal to xy, where xy represents the coordinates of a point. Check if these points make the straight line on a xy plane. So we are given with a set of coordinates, okay? So each coordinate will have an x and y, and we need to check if all those points given in the coordinates array, right, they belong to a single straight line. So they make a single straight line or not. So that is the question basically. So this question particularly is not very difficult, but it needs some geometry knowledge, right? So basically, if we are given with the points on the xy plane, how can we make sure those points will be on a single line, right? So for that, we need some geometry knowledge. So the knowledge that we need for this problem is the slope, how to calculate the slope given 2 points. So 2 points are the coordinates xy. So two coordinates x1 y1 x2 y2, if those are the coordinates, right? How to calculate the slope. So that is what the knowledge that we need. So here I have the formula to calculate the slope for given 2 points. So let's say the 2 points are x1 y1 x2 y2, right, as I noted down on the right side. So the slope is y2 minus y1 by x2 minus x1. So that is the formula that we are going to use for solving this problem, okay? So let's go ahead and try to understand what is there. So there can be two possible cases, right? So if they are all on the same line, so the thing that what we are going to say is each adjacent points, if they have same slope, right, each adjacent points should have same slope. Essentially, if there are like 10 points, right, let's say I'll say there are, let's say, 3 points, right? So this is P1, I will call, this is P2, P3, P4, right? So P1, P2 slope, let's say M1, right? Let's say it's M1. So P2, P3 slope should also be M1. Otherwise, we will say the points will not make a straight line. Similarly, P3, P4 should also be M1. So if that is the case, we will say all those points are lying on the single straight line. If the slope is not same, we will say okay, they are not falling in the same straight line. So the thing is, there is one more thing. When we calculate the slope, x2 minus x1 can become 0 for given 2 points, right? So we don't know what points we are going to get. So x2 minus x1 may become 0. We will get a divide by 0 error. So that means what we call for those points is the slope is undefined or infinity, right? So we will have to consider like two cases. The slope is a valid number and the slope is an invalid number. So invalid number will have only when x2 minus x1 becomes 0 for two given set of points. So those are the two cases that we are going to tackle individually, okay? So first thing is, let's say the first case is the slope is a valid number. So the cases I have written down, case 1 and case 2, right? Case 1, the slope is a valid number. That means x2 minus x1 is non-zero. So when it is non-zero, we can get some slope, right? Some number. So what we are going to do is, if the number of coordinates is 2, so if the number of coordinates given is only 2, that means there are only 2 points in the input. In that case, what we are going to say is true, because any 2 points we can connect them through a straight line on an xy plane. It doesn't matter where they are lying, right? So any 2 points on an xy plane we can connect with a straight line. That's why if the number of coordinates is 2, we just simply return true. It doesn't matter where they are, right? And the second thing is, if there are more than 3 coordinates or greater than or equal to 3 coordinates, we will say, right, greater than or equals, right, or equals to 3 coordinates, 3 or more, it doesn't matter, then we have a real problem to solve. What we are going to do is, we will do a slope calculation like this one, with this formula y2 minus y1 by x2 minus x1. Okay, so we do calculate the slope for the first 2 points, okay, and store in a slope variable, and calculate the slope of subsequently every 2 adjacent points. Just like we said, when p1, p2, p3, p4 are the points, right, we calculate p1, p2, p2, p3, p3, p4, right. So that many slopes we are going to calculate, right. So when we calculate for every 2 adjacent points the slope, right, we call that as m. Okay, let's call that as m. So if m is not equal to the slope that you calculated, then you immediately return false. So as long as all m's are same as slope, then only you have to return true. So this is all valid for a slope which is a valid slope, that is a valid number. It could be anything, right. And the case 2 is when the slope is invalid number. That means x2 minus x1 became 0 at any given point in time, right. So if that is the case, this is a corner case, right. So we will say x2 minus x1 is equal to 0. That means it's a divide by 0 error, right. So in that case, we will have to tackle it differently. So check if the first 2 coordinates x2 minus x1, whether it results in a 0. If so, all other coordinates x2 minus x1 should be also 0. In that case, we will say, okay, all of them are on the same straight line. Otherwise, they are not. Okay. So basically, the slope should be same as long as x2 minus x1 for every 2 consecutive coordinates is 0. Even in that case, we will say it is lying on the same straight line. So these 2 are the cases that we are going to code. So first thing is, we will have a method we will have a function to calculate the slope first. Okay, so let's go ahead and look at that first. So we are jumping right into the code. So I have a calculate slope. I am passing x1 y1 and x2 y2. So it is the same formula that I have. So since we are going to have division, right, so the most likely the division will fall into a double. So that's why I am converting it to a double. Okay, so y2 minus y1 by x2 minus x1. It is the same formula that we discussed. So this is the same formula, assuming that x1 and y1, x2, y2 are the 2 points. So now that we have the slope, right, the slope calculation method. So what we are going to do, so we have given the coordinates as input. If the number of coordinates is less than or equal to 2, right, just say return true. It doesn't matter, whatever. We don't need to do any check whatsoever. Otherwise we will have a problem. That means 2 cases we had, right. So 2 cases is, one is valid slope, 2 is invalid slope, right. So we have the same thing. So here I am calling y line as the invalid slope. So this is invalid slope check, right. So that means, so coordinates of 1, 0. So basically this coordinates is given as 2-dimensional array, right. So typically they are in this, right. So let me copy this and paste it into our work area, right. So like that it is, right. It's a 2-dimensional array where each row is again having 2 columns, right, where each row has 2 columns. So first row, the first one is corresponding to x and the second one is corresponding to y in the same way. So this is x1, y1, x2, y2, x3, y3, x4, y4, x5, y5, x6, y6, because there are 6 points we have in here, right. So likewise, so now we are checking whether the slope is valid or invalid. So that means this is coordinates of 1, 0 and 0, 0. So 1, 0 is nothing but x2 here, right, x2 minus x1. We check if it is 0. If it is 0, then we say, okay, it is actually a invalid slope. In that case, what we are going to do is, all the subsequent slopes, I mean the x2 minus x1 should be also equal to 0. If they are not, we just directly return false. That's what we are going to check, right? So this is actually the case 2, okay, what we talked, case 2 from our explanation, right? So now come back to case 1. So in the case 1, what we are going to do is calculate the slope for the first 2 points, right? So 0, 0, 0, 1, 1, 0, 1, 1, right? So these are the first 2 points. So you calculate the slope and keep it in the slope variable. And starting from 2 till the coordinates length, calculate the subsequent slopes. If it becomes 0, then you return immediately false. Otherwise, just check the slope again. If it is not equal to the slope calculated in the line 53, right, the first slope, then also you return false. So essentially what we are doing here is, for every subsequent 2 coordinates, we are trying to calculate the slope and put into m and see if that m is equal to slope or not. If it equal, then we are fine, but if it is not equal, we return then and there. And finally we go through the entire thing, right, whether if or else. We come here and return true. That means we have not hit a false case, means all the slopes are same essentially, right? So that's how this code is going to work. Let's go ahead and look at the time complexity and space complexity for this algorithm, right? So time and space, right? So let's say if there are n points, right, n points in the coordinates, okay, so n points. So when I say n points, right, so in this example there are 6 points. So there are 6 points. Each point has 2 things, right, x and y, right? So that means 12 totally, but we will say, since they are points, we are going to say n points. The numbers in the n points are, each point will have 2 numbers, x and y, right? So there are n points. So if there are n points, we are going through the entire n points one time through this for loop, or even for this for loop, right? So that means the time complexity for this algorithm is order of n, okay? So there is one thing that we have been calculating, right? So that is the slope. So slope calculation is given 2 integers, it is just a division, right? So I mean given 4 integers, it is subtraction and division. So we can say calculate slope is constant time irrespective of the x or y, right? So we will say that's why the time complexity for this problem is order of n. And let's look at the space complexity. Space complexity for this algorithm is, are we using any additional space here? We probably are using space for Boolean variable and a slope here and a slope m here, right? But these are constant irrespective of the number of inputs that you are given with, right? So the space we are not really using much, so which is called as order of constant space, that we will say order of 1. So this is a constant space, right? So the time complexity is order of n, where n is number of points, and space complexity is order of 1, that is constant. So this is a constant space and linear time, that is order of n algorithm, okay? So if you have any questions, please post them in the comment section below the video. I will get back to you as soon as I can. I have posted this code to GitHub repository. You can find the link in the description below the video. If you haven't subscribed to my channel yet, please go ahead and subscribe and also share among your friends. Please click on the bell icon when you subscribe so that you will be notified about my future videos. Thank you for watching. I'll be back with another problem soon. Till then, stay safe. Goodbye.